So welcome to section 6.5. I'm going to put a little audio in here for you. A complex rational expression or a complex fraction is a fraction in which the numerator and denominator contain fractions. Rational expression is the same thing as saying a fraction. Type 1 to simplify is to rewrite as a division problem and simplify. One of the reasons why I call these type 1 because you'll notice there's one fraction on the top, one fraction on the bottom. One term top and bottom. So we're going to rewrite this as a division problem. We don't divide by a fraction, we multiply by the reciprocal. We cancel the x's, we cancel the 2 into the 6 3 times, we get 3 over y. Second example, rewrite that as a division, flip it, and then we'll start to cancel. 4 goes into 8 twice. X squared minus 9 will factor to be x plus 3x minus 3. We'll cancel the x minus 3's, and you have x plus 3 over 2. Next, write it as division, flip that second fraction, and start to factor. And as we learned in simplifying earlier, always start with the easiest binomials and trinomials. Factor out the 4. 4 times x minus 2. What two numbers multiply to be 6 and add up to be negative 5? Minus 2 minus 3. We like those 1x squareds. They're easy to do. Next, that technique we talked about before in class, only the 3 can divide in with this 3. This is the only binomial right now that has a chance, so I'm going to make a guess. And then I'm going to have a 2x to multiply to x to get 2x squared. And to get a positive 3, I have to have a minus 1. To double check it, 2x times minus 3 is minus 6x. Minus 1 times x is minus 1x. Negative 6 minus 1 is negative 7. It checks. My next trinomial, these two binomials have a chance. 2 can divide into 2, 1 can divide into 2. 2 can divide into 6, x can divide into 6x squared. X minus 3 does not have a chance. Besides that, we already have it up here. So before I make a guess, I'm going to start to break down my factors. The 6 is 3 times 2. The 2 is 1 times 2. So remember, this is 3x and 2x. So 2x and maybe a minus 1. Let's go with that. And I'm pretty sure that's a good guess because I can't match up 2x with a 2 because then there'd be a GCF of 2 and there's no GCF of 2 in the trinomial. So I'm going to go with 2x minus 1, get rid of the 2 and the 1. Then a 3x, and to get to a positive 2, that has to be a minus 2. So to double check, 2x times minus 2 is negative 4x. Negative 1 times 3 is negative 3x. Those two add up to be negative 7x. It works. Cancel away. 3x minus 2 over 4. Type 2 is we're going to multiply every numerator by the least common denominator of the individual denominators. Now I call it type 2 because you'll see two fractions or two terms in the numerator and or denominator. Sometimes there's one, but if there's two, then we want to use this technique. So we're going to look for the least common denominator of the individual denominators, 4, 8, 2, and 16. 16, that's my LCD because 2 goes into 16, 4 goes into 16, 8 goes into 16. Multiply all the individual numerators by 16. What I'm really doing is simply multiplying 16 over 16, which is 1, to both the top and the bottom. So I'm not changing its value by multiplying by 1. Time to cancel. 4 goes into 16 4 times. 8 goes into 16 twice. 2 goes into 16 8. 16 goes into 16 once. 4 times 1 is 4. Plus 3 times 2 is 6. 8 times 1 is 8. Minus 5 times 1 is 5. Add the top 10, subtract the bottom 3. There's my final answer. Looking at our next example, looking at the two individual binomials, that's going to be my least common denominator because if they're not the same, then we just multiply them together. So we multiply that to this x. We multiply it to this 1. And we do have to multiply to this 1, even though there's no fraction here. What I'm going to do, though, is because this is going to give me a difference of perfect squares, I'm going to multiply it by x squared minus 1 when you FOIL it out. Then cancel the x plus 1 and x plus 1. Cancel the x minus 1's, and you have x times x minus 1 on the top, x squared minus 1 times 1, no change, plus 1 times x plus 1, there it is. So distribute the x on the top, you can get x squared minus x. On the bottom, the minus 1 plus 1 cancels, so you have x squared plus x. Wait a minute, let's go back to our numerator because there's x's in every term, so you can factor out an x out of the top and the bottom, and then cancel those x's for a final answer of x minus 1 over x plus 1. Next, we have x minus 7, x plus 7, which happens to multiply to be x squared minus 49. So this just happens to be going to be my least common denominator. Now this time, instead of writing this all out and just to draw lines through them, I'm going to look at it this way. I know this fraction is going to cancel the x minus 7 with that x minus 7, so only the x plus 7 is going to be multiplied to the 2. This x plus 7 cancels with that x plus 7, so I'm going to multiply by x minus 7. Less writing. X plus 7 is going to cancel, so times that 6 by an x minus 7. Everything cancels here. So I have 2 times x plus 2 times 7, that's going to be 14. Minus 1 times x, that's going to be minus x. Negative 1 times minus 7 will be plus 7. Watch that sign change. And on the bottom, 6 times x is 6x. Minus 7 times 6 is minus 42. Minus the 1. And then we combine like terms. 2x minus x is x. 14 plus 7, 21. Minus 42 minus 1 is minus 43 with your 6x. And there is how we simplify our complex fractions.